Okay, welcome everyone to another live recording of our 7 Investing podcast. Today is September 21st, 2022. My name is Simon Erickson. I'm joined by Dr. Anirban and Simon. We are both lead advisors here at 7 Investing. We do have an ongoing podcast. And Anirban, we've been having some fun lately. We've been mixing these up and actually doing it in front of a live audience.
Love it. Yeah, it's great to do it in front of a live audience. Sometimes we have a little bit of tech challenges, but today actually we got off without any challenges, which is awesome. And it's great to do this live. So it's not scripted, and we can have our back and forth, and it's great. We do some prep, but it's not that we don't prep, but we do some prep. But yeah, it's great to do it in this live format, and we love taking questions.
Yeah, absolutely. It is a little bit more fun, more interesting when you have a live Q&A, and not quite as scripted, like you said, as for several of our other podcasts. We did just record a couple last week that we're rolling out to our podcast this week on Snapchat, and then also on Upstart. And I think that it's kind of neat to kind of have the back and forth conversations with investors about a lot of these companies. For those who are unfamiliar or have never heard of 7 Investing before, our site is 7investing.com. We offer 7 stock market recommendations each and every month. We are long-term investors. We are buy and hold investors. We're looking for the best opportunities we want to hold on to for at least 3 years. So come check us out. And if you do want to actually see our recommendations, 7investing.com/subscribe. Promo code 7 will get you the first month for $7. That's a significant discount. And thank you for listening to this podcast. Anirban, today we're going to be talking about custom chips. You and I kind of really are interested in the semiconductor industry, also in the big tech industry. And there's kind of been a fascination several years now, but it's been big companies that are tech companies designing their own chips, right? It's not just going to Intel. It's not just going to, NVIDIA or AMD or somebody and saying, hey, what have you got that we can do this for? We've got kind of hyperscalers. Now we've got some tech companies that are growing quickly. They want to make processes as efficient as they possibly can, and that's leading them to actually bring a lot of the design in-house. Any other thoughts about what's going on out there as we're looking at some of these companies?
Yeah, at a high level, I guess, one of the things to ask is why do big tech or why do companies want to design their own chips? Previously in the past, right? You basically, if you wanted to make a computer, or you just go to someone like Intel, you take their chip and then you design your computer. But I think one of the issues that you discover is as these chip making companies, they basically became duopolies or triopolies or quadpolies and things like that, right? Then they got immersed in their own, I would call it their roadmap, right? And they had their roadmap, which then meant that those people, for example, designing, say, Macintosh computers, they would have to then follow the Intel roadmap to figure out, well, which chips to use, what can we do, what's the power performance trade-off, and what can we enable based on those chipsets, because ultimately, that's running the assembly language code, right? So your operating system is going to run on top of that, and there's limitations, capability limitations are going to show up. So I would say a little bit, people got tired of the roadmaps being, you have to follow somebody else's roadmap, and people got, and it limited. Also, the other thing to remember is that people, when you are designing for so many people, you're going to design for a common, a common good. There's a common, it's almost like a political, it's like multiple political parties coming together to form a government, like it happens in, in a minority government. Many people come together, which means the agenda is really of the mixture, which means, it's a common agenda, but which means that, the big tech companies wanted to design their machines based on a certain principle, couldn't really do it that way because they had to follow the principle of the common, or the common ground, or basically what the chipsets offer. So I think that sort of led some companies to start thinking about, specialized design, more hardware, software control, and things like that. So, yeah, I think that sort of led to the stage currently that we are in.
I think so too. I think it's a fair statement that every company, or most companies, are a tech company now. They're not only putting chips locally into the devices they're selling to us or that we're using, but they're also building out their own data centers. And, we've talked a lot about cloud computing, training AI models. A lot of this is actually being processed in neural networks that are in the data centers that are now owned by these tech companies that are learning and training the devices that we're buying from them. So kind of two levels of this. I wanted to maybe set the scene a little bit about what this means and kind of how companies play a part in this ecosystem. And then we'll look into some of the actual specific examples of tech companies that are designing their own chips and who they're working with. But just to kind of set the scene or the table on this, there's kind of three levels. There's the companies that are providing the application or selling the product to the end consumer at the end of the day. This is the Teslas, this is the Apples, this is the Microsofts, whoever it might be. But a lot of times as they're designing their chips that are going into those products, they're working with designers. They're working with chip designers themselves. And this was, like you said, the greatest good or the other's agenda. There were companies like NVIDIA or AMD or even Intel that kind of made chips that were high performance and more efficient. You get more and more workload efficiency per power consumed for each one of these. But then companies started, kind of saying we wanted to work with other businesses to design these from the ground up for us. And so there became a new layer of ASICs, of application-specific integrated circuits, companies that would design the chips for you. You could then go out and manufacture them. And the third layer, of course, is who's actually manufacturing these at the cheapest possible cost, at the highest performance you can. And so when we're talking about this, we're going to be talking about the end companies that are selling the products of whatever they're putting the chips into. We're talking about the designers who are helping those companies make those chips. And then we're also talking about the manufacturers who are actually running the fabrication facilities that are actually producing the chips and delivering them to the customers. So let's start with a fun one, Anirban. I know that you are a really big fan of this company, but Apple. Apple is making a lot of its own chips that are going into smartphones and other smart devices. You followed this one for several years now. Kind of what's the story of why does Apple want to do this and who's it working with?
Yeah, so Apple basically started making its own chips first with the iPad. So I think one of the first iPads came up with what they call the A4 chip. Then they sort of used that chip. That was the starting point. And at that point, that chip was just basically I think just a CPU, not even integrated with the GPU, or if my memory serves me right. And then later on, that same chip then got put into, I think, the iPhone 4. And since then, basically, Johnny Shoji, who leads their hardware or their basically the processor side of their business, they basically, they continued making the chips. They continually improved chips for the smartphones. And I think their rationale was that, one way to stay ahead, how do you stay ahead in terms of power and efficiency on that curve? How do you stay ahead of competition? Well, you can stay ahead of competition only if you design your own chips, right? Because if you use the common chip that's out there, well, then the performance the benefit's only going to come from software, right? Not from hardware. So any performance benefit that you got, and then they would not show any differences really on, say, when you run benchmarks, for example, right? So if you run benchmark tools, you're going to get the same thing because it's an Intel chip or whatever, whoever else provided that chip. So I think that started their journey, but I think it allowed for much tighter hardware, software control, right? And that philosophy, and then the ability to sort of use the latest technology that's available, so you can go smaller, has allowed them actually to go into wearables much better than any other company has, right? Basically, Apple owns the wearable industry largely because they had that experience of designing chips for the smartphones, which then allowed them to design chips for the AirPods and now the AirTags and the chips for the Apple Watches, right? And that just is a substantial benefit because what they could do there, in the small form factor, was just phenomenal. And they've taken that experience and said, well, one way to give the Mac, the latest one, one way to give the Mac a significant leg up is to design your own chips. Change the architecture. So go to a 64-bit architecture. This is an ARM-based design. Yes, it involves changing the applications that were running all on an Intel-based design previously, but they designed essentially an emulator on the top of the Intel-based machines to allow for the software to be changed And even for the software that's not changed, they could still run on the emulator. So there's something called Rosetta that runs on the machine, and you could still run that Intel software. And now the Mac sort of has the performance that at that class nobody else has, right? And significant battery life improvement, for example, my Mac, the M1 Mac. You just turn it on and it just boots. There is no spinning of the wheel; it just turns on. So that is from a user's point of view, from an ordinary user's point of view, that's phenomenal. But then the stuff that happens is just zippy, it's fast. There's no lag in anything. And then for pro users, it means a whole lot more because they can do so much more, whether it's video editing or writing, compiling code and running stuff on it, right? So I think it's the edge that you can get by bringing the hardware and software design all together, and no one does it better than Apple when it comes to thinking about hardware and software integration and making the experience one whole experience. So I think that was the motivation and getting out of, and as you has just alluded, it just is a fact. It's just breaking out of the loop or the cycle of somebody else's development windows, right? You don't have to follow that anymore. You basically, I think you're gated by the companies that actually produce these chips. That's your gating. If you know when your chips can be produced, then that's the gating factor.
It's the perfect example of hardware and software integration, right? And Tim Cook, we've always praised him as a supply chain master, right? Like he's integrating a lot of things. And, at the end of the day, you want battery power to last as long as possible and run as many applications with the best camera that you possibly can have in your smartphone or any of the app devices. And so it makes sense. Apple did it in-house. They've got deep enough pockets to design all of these chips. They are manufacturing them with a third-party manufacturer called Taiwan Semiconductor. This is a familiar name for those that are 7 Investing subscribers and have heard us talk about this several times. But this is a company that has kind of pushed process technologies to the limit. Moore's Law is something we talk about all the time of, how many transistors can you pack as densely as possible into an integrated, so into a chip that's going to be used for a certain process. And Taiwan Semi has done this better than anyone else on the globe, including its largest competitors like Intel and like Samsung. And it's worked with Apple as his number one customer for years now, Anirban. This has been the manufacturer of Apple's chips. They're dependent on each other. Apple doesn't want to go out and spend, $30 billion on each one of the cutting edge fabs that it could do. It wants to say to Taiwan Semi, we've got to the design. This is what we want our next evolution iPhone to look like. Tim, it's been a great relationship for them for several years.
Absolutely.
So great.
No, go ahead.
Yep, and Apple. Go ahead. I'm sorry, Anirban. Go ahead.
I was saying, go ahead.
Apple has been a consumer electronics powerhouse for years. They do not run, a cloud service infrastructure, but Amazon does. And Amazon Web Services has been kind of another one that has been one of these tech companies that has really got a use case for designing its own chips. When you're talking to Alexa, and we all know who I'm talking about there, and I don't want to trigger anyone who's listening to this podcast in the background, but whenever you've got the smart speaker in your home that's responding, it does it incredibly quickly. And there's applications built upon that. You've got to have natural language processing so it can understand what you're saying. You've got to have inference so it can understand the words. It's not just a command prompt all the time. And then it's obviously got to respond to you with the correct answer. And a lot of that same kind of process is built into AWS, the same functionality for its web infrastructure and the applications that are used there. And so Amazon a couple of years back said, hey, it'd be great if we could design our own custom chips for this to put into our data centers that are powering these things. And it goes out and it designs Inferencia. It actually worked with a third-party designer called AI Chip, perfectly named for the AI applications that it was working with. And then now it's actually manufacturing them again with Taiwan Semi for a lot of the production of those. But another use case, that's another one is Amazon that, kind of one of these big tech companies said, hey, this is an application that makes sense for us to do it in-house. I've seen reports that it costs between $30 and $50 million to design Inferencia. Drop in the bucket for a company that's as big as Amazon is.
Yeah, I think the important thing there again is that, if you want to design a hyperscaler, right, how do you get the edge, right? And again, the hardware and the software combo can give you a substantial edge on what type of services you can offer, at what cost you can offer, how efficient your data centers are. And I think that's, again, a classic case of, using your deep pockets to get sort of a moat that keeps, at least, you can't keep the other hyperscalers out, but you can keep at bay so many other people because they would be dependent on commodity design. right? Commodity design, maybe open source software to try to compete with Amazon. So I think those are advantages that accrue to big companies at this stage.
And so on that note, let's talk about another hyperscaler that has leveraged open source design quite a bit, and that's Alphabet, right? Formerly known as Google, who has got its own cloud ambitions lately, and as you've pointed out so many times on our own 7 investing site, is growing quickly right alongside AWS in the cloud. Alphabet is leveraging TensorFlow, right? It's got its own tensor processing units that it custom designed as well. This is one that actually brought in Broadcom to do a lot of the work with them. Broadcom is kind of designing ASICs, those application-specific chips for a customer that wants some help with kind of the building blocks of making their own chips. But again, it seems like something that Alphabet has done very well. They've used it for the artificial intelligence that they're using for their own data centers. They're using it for their own devices. You can buy Google phones out there and various other things. But my goodness, they've got so many products that have 1 billion plus users out there. I mean, efficiency has got to be the name of the game for a company like this. Maybe some technical problems in Anirban. I hope you are still with us, but Alphabet, just kind of a company that again has done it very well. Cloud ambitions, you can kind of see the direction that they want to go. Anything else to add on a company like this? They certainly have a lot of demand for their products out there.
Look, I think Alphabet's trajectory here is very similar to what I guess Amazon has done, right? They have perfect use cases, very similar to Amazon in many ways, and it makes sense for them to again own the design, because then you can design custom hardware, custom software again. Yeah.
It's interesting too, because Alphabet is taking things a step further and is designing quantum computing chips now. Mm-hmm. Their Sycamore processor, they want to actually have a completely different architecture, different than a CPU, different than a TPU. This is now a quantum computing processing chip that they're starting to play with right now. They might open something like that up to commercial business in the near future here, similar to like what they're doing with a lot of the applications in Google Cloud Platform. But again, kind of pushing the limits, deep-pocketed tech company doing some cool design work for chips. Got to applaud Alphabet for that. Let's talk about another one in Anirban that you're a big fan of, Tesla. Tesla is incorporating chips not only in its cars, but also in the data centers that it's using to train a lot of those vehicles. What can we talk about with Tesla? I know this is the one that you're a big fan of.
Yeah, so I think this one is interesting because sort of if you think about what they're trying to do. So in the car, for example, they have custom chips that, what they call the FSD computer. So basically, their vision system sees stuff that whatever it sees needs to be processed, on the logic, and needs to be processed quickly. Right, so they have these two chips, custom chips on the, one is basically a fallback chip on your car that basically processes what it sees and then makes decisions, right? So again, it's a classic case of a very specialized problem, right? It's not a general problem that they're solving. They're solving a specific use case, and therefore having a chip that satisfies their power requirements, satisfies their compute requirements, satisfies their latency requirements. All of those things are important, and and their chip is not as advanced. For example, the one that's in terms of at least process technology, if I remember correctly, it's like I think a 14 nanometer design, and it's probably like 3 years old now. When they were using 14 nanometer, I think Apple was using a 7 nanometer design at that time. So it tells you that they went for the cheaper fab option there, and I think Samsung was their designer. But there's nothing that says the way it's designed is you can take out the chip, because it just basically is like it's a small little thing that just is going to plug into the board. So you can take it out and you can swap it for another one, because before hardware, this is called hardware 3. Before hardware 3, they had another design or another chip that they were using, which was called hardware 2, and then there was hardware 2.5. I'm very sure that at some point there's going to be hardware 4 and hardware 5, and it makes sense because on the one hand, as you noted, they have the neural network training that they do on a computer called Dojo. That's again internally designed with internal chips on it, right? So you're designing the algorithm is being created there, or the training of the algorithm, but then the algorithm's output basically runs locally on the computer on the machine here on the car. So eventually, as the algorithm's complexity increases, it's not going to run on this machine, on the machine in the car. You need a more performant machine in the car, and therefore you need to upgrade. So that's, and again, here it makes perfect sense because you can control the design cycle. If the hardware is the limitation, then you can change the hardware very easily, and you can design the hardware to work as required for your application instead of depending, for example, on, say, a solution from NVIDIA. When Tesla first released its chip, one of the comparisons that they did was with NVIDIA's best-in-class chip that was being used for self-driving applications, and they claims in terms of, say, teraflops, for example, that their machine was significantly better than NVIDIA's, right? And NVIDIA had to write a blog saying, "Oh, we appreciate what they're doing, and ours is better this way." But again, it's a validation saying that, look, this is very good. But now they're sort of decoupled themselves from the NVIDIA loop, which is what a lot of these other companies would be using. They'll be depending on NVIDIA's loop. And there's nothing wrong with that. I think the manufacturer or the system at scale can afford to design it. Not everyone can. So you need a designer who's going to take care of the others, right? Which in this case, it looks like it's going to be NVIDIA.
Yeah, teraflops, trillions of floating operations per second. That's a fun dinner conversation term to throw out there, which is obviously something you're looking at when you're building neural networks. I love the description of it, Anirban. And again, for Tesla's cars, this is something that they went out and they just said, we're going to put autopilot out on the roads as much as possible. And we're going to train these cars with millions of miles of actual driving data. And it's going to be video, right? It's not going to be these fenced geolocations where you can drive around for 20 minutes in a small loop that's 1 mile around the park where you're collecting the data. They said, we're going to put them out there on the road, so we're going to train these vehicles with the neural networks. And that was something that Elon did very well, because like you said, there's 2 layers of abstraction from this. You've got the vehicle that's got the chips that's collecting all the data. And then you've got also the neural network that's being trained to say, okay, that's a deer that's running out in front of you. You need to stop for that, or a stop sign or whatever else it is. And so Tesla has gotten a real jump start over the Waymos of the world and the other self-driving programs just because it was collecting more data, training its neural networks, and of course, the custom hardware that it designed itself was a key factor for that as well. I'm glad you pointed out, too, that they're manufacturing with Samsung. That's a little different than some of the other companies we've talked about. It's one that Tesla's won here recently, and a big win for Samsung to have a company like that.
Yeah, Samsung...
Facebook Meta.
Can you just quickly...
Yeah, sorry, go ahead.
Yeah, so Taiwan Semi is, of course, probably the leading-edge designer in this space, or leading-edge manufacturer with the design processes. Samsung is an interesting one because Samsung is the one that Apple actually started with, and then Apple, switches between using Samsung and Taiwan Semi. And in this case, Tesla, for example, went first with Samsung. So Samsung, as you said, is one of the big 3 or 4 in this space in terms of design, and it's worth remembering what Samsung semiconductors are doing.
It's been interesting. It's certainly a fight for the most lucrative customers out there, Tesla included. One other company that's got big ambitions for making its own chips is Meta. Again, name change now. Used to be formerly known as Facebook, which of course initially kind of wanted to do these things for facial recognition and the things for the site itself. But it's got even bigger ambitions now with the metaverse. Zuckerberg has revealed that he's building data centers that are cutting edge, right? And he's putting NVIDIA's chips in there too, but Facebook's designing a lot of their own custom hardware too. I think that the metaverse is going to be very computationally heavy. We have seen Facebook working with Qualcomm for the design of a lot of the chips that are going into the headsets themselves, again, locally for the metaverse. Those are the virtual reality headsets that you put on. They're now wireless instead of plugging into a computer for the processing. But then also, again, you've got to have the data centers and the supporting infrastructure for all of the processing that's going along with this. And any thoughts on Zuckerberg and metaverse? And this is something that they're spending tens of billions of dollars on Anirban. It seems like it's perpetually a couple of years out, but there's no denying that they put the work in up front to design and spend very heavily on making this happen.
This could become a separate podcast altogether.
You're right.
So look,
grab your beer or coffee. Here we go.
Well, look, my high-level view on metaverse. So on Zuckerberg's situation, I think at a high level is you're damned if you do and you're damned if you don't. And by that, what I mean is their expertise at sort of designing hardware and software is sketchy to poor, in my opinion. Because, I mean, their hardware till date, whatever they've designed, the Facebook phone, the spying camera or whatever they had, speaker, all of them are actually royal flops, right? I mean, those, they're just as big a flop as an Amazon Fire phone. And so I don't think they have anything that they can write home as success in the hardware front. For a company like that to then think that they can actually design hardware that's going to be super successful is actually quite bold. But what do you do if you don't? Because otherwise you're going to be, ruled over by what the other OS platforms are doing. So I think that's where their situation is. So they kind of are in that boat. I think it's smart for them to focus on designing the chips for the hardware or for the data centers. But here's an interesting thing. I get why Amazon designs chips, because they actually have a service called AWS, and a lot of stuff requires that chip performance and cutting edge design. I get why Alphabet does it. I don't get why. Now, as a comparison point, my favorite company in terms of, being spendthrift in terms of how you actually deploy capital is Apple, right? Apple does not design chips for the data centers, because you can use what Amazon and Google provide, and that's what they use. So it is not clear to me that Facebook couldn't get away by by leveraging AWS or Alphabet's infrastructure, or even Microsoft's infrastructure. So a lot of their bet, I think, is far out, and it's a bet that, we will get something out of this. So they want to have the design experience. The way I look at it, they want to have the design experience. Therefore, that design experience can then feed into some of their products, which therefore may allow them to control the metaverse. And they look at Apple as the biggest enemy. What I say is, fine, you look at Apple as your biggest enemy because they're giving you a gut punch because of the ATT, but you're forgetting that Alphabet is out there, and Alphabet controls Android. And what makes you think that Alphabet is going to let someone else have the underlying operating system for running a metaverse, as an example, if metaverse is ever to realize into anything? So yeah, in many ways, I would say I would draw comparison for Facebook's spending. A lot of what they're doing is very similar to what Snapchat is doing. The only difference is that Facebook has huge amounts of free cash flow that it can actually deploy. Whether that money burns or the money actually delivers a return on that investment, we don't know. But it seems like the strategy is very similar. You're basically throwing a few darts out in the wild, and maybe one of them hits the bullseye.
And to be fair, Zuckerberg has a lot riding on metaverse, right? He renamed the entire company to show the priority that he's putting on this. I would say that the vast majority of people, I think this is a fair statement to make, are not in the metaverse today. They don't have virtual reality headsets that you're putting on when you come home. This is something that, again, Zuckerberg loves to be the visionary, loves to do things that he's saying will be very, very common and very, very popular 3 to 5 years out. But again, it's a huge bet. You can't mess this up. If the latency is still bad for the headsets, or it's a bad experience in the metaverse, or they don't have the privacy controls, all these kinds of things that are huge factors that are going to take years to figure out. If the experience for the consumer is bad, it's a lot on the line for a company that's as large as Meta. You've got to applaud his ambitions, but at the same point, you've got to make sure that they're going to do this right. And that goes for, as we just mentioned, not only the headset and the local processing that's going to be ridiculously computationally heavy, but also for the back-end infrastructure as well. So, like you said, maybe we should have a follow-up podcast on just Meta and Facebook, because there's a lot going on. It's not just a website where you're sharing your interests anymore.
That's right. Yeah, I agree. That's maybe a fodder for another time.
Yeah, and so great. So, here we are. We kind of highlighted a couple of companies, a couple of big tech companies. I want to be respectful of time. We're coming up on the 30 minutes past the hour. But we chatted about Amazon. We chatted about Meta. We chatted about Tesla. We chatted about Apple. And we chatted about Alphabet. All of these are tech companies. But that has been more and more important for the computation of whatever it is those tech companies are wanting to do. And so Anirban and I, we both have all these kind of fun conversations that I always enjoy chatting about him, about the semiconductor piece of this, the hardware piece of this. And it's like, how does that figure into the bigger picture? Who are they working with for the design of these chips? Who are they working with to manufacture these chips? And we hope that we shed a little bit of insight on how that looks and how that could be interesting for all of us as individual investors as well. Anirban, I always enjoy these conversations with you. Thanks for being part of the live broadcast here this afternoon.
Thank you for having me.
And thanks everyone for our live audience. Appreciate the people that showed up and were here with us live. Once again, if you are listening to our podcast on our other channels, 7 is the promo code to use. The number 7 at 7investing.com/subscribe. If you would like to come check out our recommendations every month. Anirban this previous month went with a company that we all know quite well, but my goodness, we're getting a fantastic valuation on it right now. So come check out our stock recommendation, 7investing.com/subscribe. Again, 7 is the promo code for that. That wraps up today's podcast. My name is Simon Erickson. We are 7 Investing, and we are here to empower you to invest in your future. We hope you have a wonderful day.